The future of space exploration lies not only in the hands of astronauts but also in the precise movements of robotic explorers, controlled from millions of miles away. Imagine a scenario where robots on the Moon or Mars are remotely operated by human controllers on Earth, with the ability to dig, assemble, or collect samples as if they were physically present. This vision is quickly becoming a reality, thanks to advances in teleoperation technology. Robots have already played a critical role in past missions, such as the rovers sent to Mars, but there are limits to what they can do autonomously. Communication delays, especially between Earth and distant locations like Mars, introduce challenges that make it difficult to control robots in real time. This is where teleoperated systems come in, allowing humans to control the robot's actions from afar with a level of precision that surpasses traditional remote operations. Recent advancements in teleoperation have made significant progress. Researchers from the University of Bristol, working in collaboration with the European Space Agency, have successfully tested systems that allow operators on Earth to control a robotic arm to dig into lunar soil. What makes this groundbreaking is that the process eliminates the need for video feedback, which can lag due to the time it takes for signals to travel between Earth and space. By using virtual simulations combined with haptic feedback, the sensation of touch, operators can now feel the texture and resistance of lunar soil as if they were handling it themselves. This breakthrough opens up a world of possibilities for space exploration, offering the potential to not only perform more complex tasks remotely but also overcome one of the most significant barriers in space operations: time delays. With human ingenuity and robotic precision working together, we stand on the verge of a new era of exploration beyond Earth's atmosphere. If you're as excited about the future of space exploration as we are, don't forget to subscribe to our channel. Stay updated with the latest innovations and join the conversation as we explore the limitless possibilities of the universe. Teleoperation technology is not just a theoretical concept, it's being actively developed and tested with remarkable results. In recent trials, researchers have taken the first steps toward creating a system where humans on Earth can control robots on the Moon or even Mars, with an unprecedented level of precision and responsiveness. One of the key breakthroughs has been the ability to bypass the frustrating time delay caused by the vast distances between Earth and these celestial bodies. Imagine controlling a robotic arm on the Moon from a lab on Earth, and instead of relying on delayed video feeds, you are interacting with a virtual simulation that mimics the lunar environment in real time. That's exactly what the team from the University of Bristol has accomplished. By using a combination of virtual simulations and haptic feedback, they've allowed operators to feel what it's like to work on the Moon's surface. This technology replicates the sensation of digging into lunar soil, giving the operator a tactile sense of how much force to use when scooping up material. It's as close to being there as you can get without actually leaving Earth. The haptic feedback component is especially important because it provides a physical interaction with the simulated lunar environment. Instead of just seeing a robotic arm move, the operator feels the resistance of the soil, the weight of the scoop, and even how lunar gravity affects these movements. In the current simulations, basic tasks like pressing a scoop into the lunar surface or dragging it through the regolith are being perfected. While these tasks might seem simple, they are the foundation for more complex operations in the future, such as assembling structures or gathering samples with precision and care. But the technology doesn't stop at simulating the Moon's gravity. The system can adjust to different gravitational forces, which means it can also be adapted for missions to Mars or even asteroids. This flexibility is critical as humanity pushes further into space. Mars has a different gravitational pull from the Moon, and understanding how tools and robots behave in these varying environments is crucial for success. The researchers are also looking at how this teleoperation system could train astronauts. With realistic simulations of the Moon's conditions, astronauts can practice mission tasks on Earth before they ever leave the planet. This could save precious time once they arrive and ensure they are fully prepared for the unique challenges they'll face. As this technology continues to evolve, it's clear that teleoperation is poised to revolutionize how we approach space exploration. The combination of virtual simulation, haptic feedback, and real-time control will allow humans to do much more from Earth, paving the way for a more efficient and expanded presence on the Moon, Mars, and beyond. In the next section, we'll explore the psychological aspects of trusting these virtual systems and what needs to be done to ensure they perform flawlessly when it matters most. As the development of teleoperation technology progresses, it's not just the physical capabilities of these systems that matter, there's also a psychological component that can't be overlooked. For humans to effectively control robots from such great distances, they need to trust that the virtual system they are using is not only responsive but also accurate. This trust is essential because, in a remote environment like the Moon or Mars, there's little room for error. One of the key challenges that researchers have identified is the trust gap that exists between operators and virtual systems. When you're using a teleoperation platform, particularly one with virtual and haptic feedback, there's always a lingering doubt in the operator's mind: is what I'm feeling and seeing on the screen truly representative of what's happening in real life? For example, if a robotic arm appears to scoop up a sample of lunar soil in the simulation, can the operator be 100% sure that the action was completed correctly on the actual surface of the Moon? This uncertainty has been studied in detail by the team at the University of Bristol. Their goal is to quantify how trustworthy their system is and to bridge this psychological gap between operators and their machines. Early results are promising. During tests, their system was found to be efficient 100% of the time when scooping up simulant lunar regolith. Trustworthiness, measured by the operator's confidence in the system, was rated at an impressive 92.5%. These numbers are encouraging, but they also highlight an important area for improvement. The act of pouring out the regolith from the scoop, for example, was less reliable. The team discovered that by limiting the orientation of the scoop, they could improve the precision and reduce errors, further increasing the operator's trust in the system. Building trust is not only about improving the system's technical performance. It also involves training operators to work seamlessly with virtual tools. As teleoperation becomes more advanced, astronauts and technicians will need to practice extensively with these systems on Earth before deploying them in space. They'll need to build muscle memory and instinct for using the tools, learning how the technology behaves in various simulated environments. With enough training, the psychological barrier can be lowered, and teleoperators will gain the confidence needed to manage even the most delicate tasks from millions of miles away. This psychological aspect becomes even more critical when we consider long-term missions, such as those planned for Mars. Unlike the Moon, where communication delays are about 1.3 seconds, Mars presents a much larger challenge with delays of up to 20 minutes each way. Teleoperation systems must be robust enough to handle such delays, while still allowing the human operator to feel in control and confident in the outcomes. Training and trust will be essential in future missions, whether it's controlling a rover to collect samples on Mars or assisting astronauts in assembling habitats on the lunar surface. The next step in this journey will be to refine these systems even further, ensuring that the technology performs flawlessly when deployed on actual missions. In the following section, we'll dive into how teleoperation could play a crucial role in retrieving valuable samples from Mars, and how it might help humanity push even deeper into space. As we look beyond the Moon and set our sights on Mars, the potential of teleoperated robots becomes even more critical. Mars poses unique challenges due to its distance from Earth, with communication delays reaching up to 20 minutes each way. This delay makes real-time control impossible, but teleoperation technology, combined with pre-programmed autonomy, could provide an ideal solution. One of the most exciting prospects for teleoperation on Mars is its role in sample retrieval missions. NASA's Perseverance rover, for example, has been collecting samples from the Martian surface, which are intended to be returned to Earth in a future mission. The complexity of this task, retrieving sample tubes from a rover and loading them onto a vehicle for launch, requires precision that current autonomous systems may struggle to achieve on their own. Teleoperated robots, controlled by humans on Earth, could assist with these high-stakes operations, ensuring that samples are handled with care and accuracy. Teleoperation also has broader applications for Mars missions. It could help astronauts set up habitats, gather resources, or explore regions that are too dangerous for humans to access directly. Even missions to asteroids or other rocky bodies could benefit from teleoperated systems, where real-time human control adds a layer of safety and adaptability that autonomous robots lack. The same principles being applied to lunar exploration today could be adapted from Mars in the near future. With further advancements in communication relays and robotic technology, teleoperation will be essential for managing complex tasks on the Martian surface, overcoming the distance between Earth and Mars while maintaining the human touch that's so vital for space exploration. In the final section, we'll explore the future of teleoperated missions and what the next decade might hold as we push further into space. The future of teleoperated robots in space exploration is incredibly bright. Over the next decade, we're likely to see these systems become a crucial part of both crewed and uncrewed missions, not only to the Moon and Mars but also to more distant and challenging environments. As technology advances, the precision and responsiveness of teleoperation will only improve, enabling us to perform increasingly complex tasks remotely. Whether it's constructing habitats on the lunar surface, retrieving precious samples from Mars, or exploring the far reaches of our solar system, teleoperation will bridge the gap between human ingenuity and the harsh realities of space. One of the most significant advantages of this technology is its ability to enhance safety. Astronauts can stay within secure environments while directing robots to perform dangerous tasks in hostile environments. This combination of human oversight and robotic execution will revolutionize the way we think about exploration. Instead of relying solely on autonomous systems, teleoperation allows for human decision-making and adaptability, which are critical when navigating the unknown. Looking ahead, the ongoing collaboration between space agencies and private companies will further accelerate the development of teleoperation technology. As NASA's Artemis program aims to return humans to the Moon and eventually reach Mars, and with other global missions on the horizon, teleoperation will undoubtedly be at the forefront of these efforts. The potential to remotely operate robots in space opens new doors for discovery, while reducing the risks for human explorers. The next frontier of space exploration will rely on this synergy between humans and machines. As we prepare for the challenges of the future, the need for precise, reliable, and innovative technology will only grow. The idea of controlling robots millions of miles away might seem like science fiction, but it's rapidly becoming our reality, and it's the key to unlocking the mysteries of the universe. If you're excited about the role teleoperated robots will play in humanity's quest to explore space, join our journey. Subscribe to the channel and stay connected to the future of exploration, where human creativity and robotic precision work hand in hand to take us beyond Earth's boundaries. Together, we'll witness the next great leap for humankind.